All right, what we're going to work on today is finding missing angle measures in right triangles using trig ratios. But before we do that, just a little review at the top for finding side lengths. And what you want to do in the problem, always try to identify what you're working with. So look for that acute angle. I've got a 26-degree angle, and then how the labels in the triangle are related to that angle. So I would say x is opposite. 42 I know is the hypotenuse. It's across from the right angle. So if I'm using my SOHCAHTOA, when I have opposite hypotenuse, that is going to be sine. So I'm going to set up my trig ratio. Sine of 26 equals the side opposite over the hypotenuse. And then all we have to do to solve the problem there is multiply both sides by 42. And I'm just using my graphing calculator here because it shows up a little bit better on the screen, but you can obviously use a scientific calculator to do this too. So just doing 42 multiplied by both sides to get that out of the denominator, and what I'm going to end up with is x is going to be to the nearest tenth, is what it says in the directions, 18.4. Question number 2, again, here's my angle. My acute angle is 41 degrees. The 9 is attached to that, and part of that angle, so that's adjacent. The x is across from the right angle, so it has to be the longest side, so that's the hypotenuse. Adjacent hypotenuse is going to be cosine, so cosine of 41, adjacent, which is 9 over the hypotenuse. Now, if you guys remember, if the variable's in the denominator, we're just going to do trading places here, and we're going to end up dividing 9 by the cosine of 41 to get our missing side there. So I'm just grabbing my calculator and just 9 divided by cosine, oops, hit the wrong button, cosine of 41. You can close the parentheses or leave them open, that won't make a difference. Hit equals, and to the nearest tenth, that's going to be 11.9. And I've got one more here. Again, here's my angle. How are these sides related to that angle? The 16 is across from that angle, so that's opposite. The x is attached to that, so that's the adjacent. I don't have a label on the hypotenuse, so opposite adjacent is going to be the trig ratio of the tangent. So tangent of 72 is opposite over adjacent. This is similar to the last problem. These are going to trade places. If your variable is in the denominator, you are going to divide. If your variable is in the numerator, like it was in this first question, all we have to do is multiply both sides to get that number out of the denominator. If the variable is in the denominator, we got to trade these places. So to get my answer for that last question, we're going to do 16 divided by tangent of 72, and to the nearest tenth, that's going to round that up 5.2. Okay, now, very important, you're going to need your calculator for what we're working on today. We're actually going to find missing angle measurements. And this is just going to be one more step on the calculator, but very similar to what we've been working on. So, find your angle. I'm going to find x here. So I'm trying to find the angle measure in degrees. So let me see how the sides are related to that. So 27 is across from that, so that's opposite. The 32 is across from the right angle, so the 32 is going to be the hypotenuse. So I have opposite hypotenuse, so opposite hypotenuse is sine. So here I'm going to have the sine of x is the side opposite, which is the 27, over the hypotenuse, which is 32. Okay, now how do we solve this equation? All right, you can't divide by a sine or divide by x here. What we are going to do is we are going to inverse the sine. So we're going to take the inverse. So what I'm going to do both sides, inverse looks like a little notation with a -1. You're going to see this on your calculator. And whatever I do to one side, I have to do to the other. So I'm going to do the inverse sine. The sine and its inverse cancel each other out. So here I will just be left with x. And then here on the other side we'll have the inverse sine. That little -1 is just notation for the inverse. And then 27 over 32. Now, excuse me, you don't need to reduce that or anything, which we're not going to be able to for that particular fraction, but you can just leave it as it is. And then you guys, it's just going to depend on what kind of calculator you have. You should be able to just find your sine button Here's my graphing calculator. You can see the second function there is just a sine inverse. And a lot of you guys have this calculator, so I just went and grabbed it real quick. Again, find your sine button and you'll see the second function there is an inverse. So I'm just going to hit second sine. That'll give me the inverse. Type in your 27 over 32. And all you have to do is hit equals here, and that will give you the angle measure. Now, when we're doing angle measures, we're just going to go to the nearest degree, which is going to be the nearest whole number. So 57.5, I'm going to go ahead and round that up. X is going to be 58 degrees here. Okay, so just for the next one, here's my angle. Figure out how the sides are related to that angle. So 8 is opposite that. 5 is attached to that or adjacent to that. We don't have a label on the hypotenuse. So opposite adjacent is going to tell me to use the tangent. So tangent of that angle there is the opposite over the adjacent. So just like what we did in the last question, to cancel out a tangent, we're going to do an inverse tangent. Inverses always get you angle measures. So on this side, the tangent and its inverse cancel each other out. And on the right side here, it's going to get me to my answer. So an inverse tangent finds you an angle measure. So again, we're just going to hit, let me use the graphing calculator, it just shows up a little bit better. So I'm going to hit second tangent. That should give me that little -1 so I can see it. Just do 8 divided by 5, hit equals, and then we're going to round this to the nearest angle. So actually that one's going to round to 58 also. So X here, 58 degrees. And I have one more. So find your angle. 10 is the hypotenuse there. It's across from the right angle, so it's the longest side. 6 is attached to that angle we're looking at, so that's adjacent. So adjacent hypotenuse is going to tell me cosine. So cosine of my angle, adjacent, which is 6, over hypotenuse, which is 10. Now, you can reduce that fraction, but you totally don't have to, because we're just going to use the calculator to help us do this. Cancel out a cosine. I got to use an inverse cosine. Anytime you're finding an angle measure, it's going to be an inverse. These cancel, so I just get x. And the inverse cosine of 6/10, grab your calculator there. We're going to do second cosine, 6/10. And I just want to show you this real quick. If I had reduced that fraction to 3/5, both of those being divisible by 2, you'll see you get exactly the same answer. So that ratio is the same, whether you reduce it or not. So it will give you the same answer. So for this one, x is going to be a 53-degree angle to the nearest degree. All right, now this example, this is basically what we were just doing. It's just set up a little bit different way. We don't actually have a picture. These are just equations, but I see questions like this pop up, SAT, ACT, things like that. So I wanted to make sure you guys could see it's really just the same problem we just did. We just actually have the ratio already determined for us. We don't have a picture. So this says cosine of x is 0.5431. It's just a very small decimal here. This works exactly like we just did. We're just going to do an inverse cosine of both sides to cancel that out. So each of these questions, like this one, I'm just going to hit second cosine. Just instead of typing a fraction, I'm actually going to just type in that decimal. Oops. So you guys can see it on the screen there. And then inverse cosine is going to find you the angle measure. I don't know the angle measure there. And just go ahead and hit equals, nearest whole number. This is going to be 57. If I don't know the angle here and I'm doing sine, to cancel out the sine, just going to do inverse sine. So all you have to do on your calculator, second sine, get that little notation there, type in that decimal they give you. And that should give you the angle, which is actually, well, if we're doing that one, we got to round that one to 57 also. The 4 is not big enough to round that up. This one, sine again, I'm going to do inverse sine here. So this is a fraction. This is a little bit more similar to the problems we were just doing. So just second sine, do 3 divided by 7. And to the nearest degree, that one's going to be 25. Then I'm just going to try these guys over here. If you have a tangent, to cancel it out, we're going to use an inverse tangent. Anytime we're finding an angle measure, we got to do an inverse. Type in that decimal. And this guy, I've got to round that up to 29. This is also a tangent, so inverse tangent, where B is going to represent our angle here, so I need to find my angle measure. Inverse tangent, 3.5, and to the nearest degree we're going 74 there. And then just one more, this is an inverse cosine. This has a fraction instead of a decimal, that's fine, just second cosine. 4 divided by 13, and nearest degree there is going to be 72. Okay, so we're going to find two things in this problem. We're going to find a missing angle and we're going to find a missing side. Now, here's one little thing. I see that I have parallel lines marked here. So top and bottom of that figure are parallel to each other. If you guys can see this, I can use this side right here as a transversal between those two parallel lines. And if this is a right angle, by alternate interior angles, this is going to be a right angle as well. So I actually have two right triangles in this diagram here. What I would tell you here, we have to find W before we can find X. So let me go ahead and do that first. With X, if I did that, I just have a missing angle and just one side in a triangle, so I don't have enough information to do that. But here I have an angle, a side, and a side, so I can use that angle measure with our trig functions to figure that out. All right, so if I just look at this 60-degree angle here, the 10 would be the hypotenuse, the W would be adjacent to that, so hypotenuse and adjacent is going to be cosine. So if I do cosine of 60, that's going to be equal to, let's see, adjacent would be the W over the 10, which would be the hypotenuse. All I have to do there, I just need to multiply both sides by 10 to get that away from the variable. So I'm just going to grab my calculator. Now, we're not going to do an inverse here because I'm finding a side length. So I just do 10, hit my cosine button, 60, multiply that. Actually ends up being a nice number here. That doesn't always happen, but that's the case here. So W is equal to 5. Okay, now here's what, I'm just going to draw this separately here. So the other variable is X, and now I know this is a right angle because of the alternate interior angles, parallel lines there. Now I know this is 5. So totally separate question here. If I want to find the angle, so from angle X here, 5 is opposite and 7 is the hypotenuse. So opposite hypotenuse is going to cause us to use sine of X, which is what we're going to figure out because we don't know the angle measure. That sine ratio, opposite over hypotenuse, would be 5/7. And anytime we're finding an angle, we got to cancel out the trig function, which is a sine here, by using an inverse. So the sine and its inverse cancel each other out. So inverse sine of 5/7 is going to give me my missing angle measure. So I'm just going to grab my calculator here real quick. So angles, we got to hit second sine, 5/7, and to the nearest degree, 45.58, we're going to have to round that up. It's about 46 degrees. Example down here is going to say solve the triangle. So we're basically just going to find any missing sides or angles. There's two diagrams below. We're just going to start with this one. I actually have all the sides labeled in this triangle, so I don't need to find any sides. We just need to find angles for X and Y. You can pick either one to start. It doesn't matter. And in this case, you have a lot of information in this picture, so it's completely up to you. There's different ways you could solve this. I'm just kind of looking at the three here, and I'm going to say, okay, that's opposite. And the 5, I could do that as the hypotenuse, which it is. And so from there, if I wanted to set up opposite hypotenuse, I could do sine of X, 3/5. Okay, now, also in the problem, the 4 is adjacent. So I could also, as an option, I could do cosine of the angle adjacent over hypotenuse. And as a third option, you don't have to do all these, you just have to pick one. But as a third option, I could do opposite adjacent. So I could also do tangent of x is opposite would be 3, adjacent would be 4. Okay, I just want to show you this real quick. You just have to pick one. Each one of these I would do an inverse to find the angle. I'm just going to show you real quick. They all give you the same answer. So if I do the inverse sine of 3/5, angle measure, we'd round that to 37. If I do the inverse cosine of 4/5, same number because these ratios are going to give me the same angle measurement here. And then if you had picked to do the tangent, inverse tangent of 3/4, every single one of those gives you the same answer. So you don't have to do all three, you just have to pick one. That's going to be 37 degrees to the nearest whole number. That's x. Okay, now, do you have to use trig to find y? You can. Or if you want to do this, you've got a triangle, right? So if I want to find, this is for x. Now, for y, I could just do 180 minus 90 minus 37 because I have two angles in the triangle. This is to find y here. And I could just subtract those two and get my angle measurement for y using that. I don't have to use trig at all. So y is going to be 53 degrees there as an option. You could also set up trig to do y. The opposite and adjacent would change. The hypotenuse would stay the same. So a couple ways you can do that for missing angle measurements. All right, and I've got one more. Now, this one, I have some different information. So I have two sides that I'm missing. I do have an angle that I know, and I have theta here, which I don't know. Now, theta, remember that's just a variable for an unknown angle sometimes. So I can actually find that super quick, just 180 minus 90 minus 62, because I already know two angles in that triangle. If I subtract that, you can have 28 right there for your theta. Okay, now, completely up to you. The more information you have, the more options you have. So I have all three angles in that triangle. If I focus on the 28, if I focus on that, A would be opposite that, and then the other side that I know, this is adjacent to that 28 degree angle. So as an option, opposite adjacent is going to tell me I can use tangent. I know the angle is 28, and the ratio there would be A over opposite over adjacent, so 22.6. Now, all I would have to do real quick there, multiply both sides by 22.6 to get it out of the denominator, times just a plain tangent of 28. I know the angle measure, and so missing side to the nearest tenth, I would actually just round that to 12. Now, I don't need to know A to get C. You have a couple options here. If you want to look at the 28 degree angle again, we could do adjacent hypotenuse here as an option. So I could just do, don't look at the A, and I would not use a side that you rounded, so I would not use A to find C. I would use this side that we know, which is the 22.6, and then the hypotenuse. I could use the other angle, that's up to you. I'm just going to go ahead and stick with the 28. Adjacent would change and opposite would change based on which angle you're looking at, but the hypotenuse stays the same. If I just go ahead and continue to focus on this 28 though, and I want to find C, I've got adjacent that I know, hypotenuse, that's going to tell me cosine. So the cosine of 28, adjacent, which is 22.6, over the hypotenuse, which is C, that's what I'm trying to figure out there. Scooch that up just a tiny bit. And if the variable's in the denominator, we're going to divide. We're just going to do some trading places here. So 22.6 cosine 28. We're not finding an angle measure. I know the angle measure here, so we're not going to use a second. Just 22.6 divided by cosine 28. And for C there to the nearest tenth, I'm going to round that to 25.6.